In this video, I decided to talk about limits because students make a lot of mistakes when they're evaluating limit problems, especially on their steps. So we have to use laws of limits when we are evaluating, otherwise you will not get marks. Okay. In this limit problem, I'm going to evaluate this square root of 1 minus sine inverse of x minus 1 divided by x. So first of all, we have to make sure what is wrong with this. So at x equals 0, the whole thing becomes 0 by 0, so which is inevaluable. Therefore, we look at the limit as x tends to 0 of this function, how the function behaves as x approaches 0 instead of at x equals 0. Okay, so after that, let's go step by step. First, look at the numerator. So you have a square root here and a minus 1 sign. So before you evaluate this, you have to multiply numerator and denominator by the conjugate of this expression. Then we can remove this square root. So let's write this. Write the equal mark, limit x equals 0. You have to write this. It is a must. Then 1 minus sine inverse of x square root minus 1 divided by x. Make sure you put parenthesis. Then 1 minus sine inverse of x plus 1, which is the conjugate sine inverse of x plus 1. You have to multiply both numerator and denominator by the same expression so that the original expressions is not changed. Okay, so next thing would be multiply these two, then you can remove the square root and you are left with, still carrying the limit, you are left with 1 minus sine inverse of x minus 1. 1 cancels out minus 1, you are left with minus sine inverse of x divided by x. In addition to this, you have this expression 1 minus sine inverse of x plus 1. Okay. So along the steps, if you find a product or a function that can be evaluated, then you have to apply the limit. Right. So using laws of limits, which says that limit as x tends to a of fx and g of x, which is a product of functions, can be evaluated separately. F of x into limit g of x. You have to make sure to carry out the limit sign. Then we'll apply the limit to both of these products. First, limit x tends to 0 minus sine inverse of x divided by x. The limit tends to 0, so we have to separate this out. 1 over plus 1. Okay, then you are left with, this will give you at x equals 0, 1 minus 0, 0. Sorry, 1 minus 0 is 1. Square root of 1 is 1. 1 plus 1 is 2. So you are left with half. Half, since it is a constant, you can carry it out to the front. Limit x tends to 0, sine inverse of x over x. Right. So I'm just gonna clear up this, and I'll take this result, limit x tends to 0, sine inverse of x over x. This is what we are left out. Now, since we don't know what this is, but we know a trigonometric relationship that says that as x approaches 0, sin x over x is equal to 1. Now let's try to make this expression similar to this. You have to make a substitution. Sine inverse of x equal y. If you make the substitution, you know that x equal sine of y. Right? After the substitution, you have to change the limit. So when x tends to 0, what will happen to y? Y also tends to 0. So now we can change the variables of limit as y tends to 0. This becomes minus y over sine of y. Half limit, let's carry out this minus sign to the front. I'm going to take y to the denominator, 1 over sine y over y. Now using the laws of limit, which says that as limit extends to a, f over g, f and g are functions of x. You can take the limits of these two functions separately. Limit x tends to a over f over limit extends to a over g. Using this property, we can evaluate this limit. Okay, minus half. I'm not gonna write it here. Now limit of a constant is a constant alone. 1 divided by limit as y tends to 0. Y sine y over y. What is this? This becomes 1. So the final answer is minus half. Okay, thank you for watching.